The year was 1815 when Napoleon fought the Battle of Waterloo. Napoleon relied on cannonball fire, but unfortunately the ground was muddy and the cannonballs dug into the mud instead of exploding upon impact with the ground and sending shrapnel to kill the enemy soldiers. A cannonball shot from a cannon, a stone thrown into the air, a ball rolling off the edge of a table, a spacecraft circling the Earth are all examples of projectile motion. In this video, we will consider the most simple case of projectile motion, known as the horizontal projectile. A basketball is an example of projectile motion. Once the ball leaves the shooter's hand and is no longer acted upon by the hand force, if there's no wind and we assume that the air resistance is negligible, the only force acting on the ball until it impacts its target is the gravitational or weight force. If a cannonball were fired from a cannon in outer space, it would accelerate to its muzzle velocity while inside the cannon barrel. After exiting the barrel, it would no longer be accelerating and then would travel in uniform motion in a straight line at constant speed. If the same cannonball was fired while on the Earth horizontally, after exiting the barrel, it would be acted upon by the gravitational force. It would then be a projectile. It can be shown that the path of any projectile is that of a parabola. Let's look at the projectile motion equation. Since the only force on the projectile is the gravitational force, which is downwards, and has no horizontal component at all, the total horizontal force on the projectile is zero. By the first law, if the total force is zero, then the velocity is constant. Therefore, the x equations for projectile motion are simply the equations for uniform motion. The initial x velocity, vx of I, is the initial speed or magnitude of the initial velocity vector times the cosine of the projectile angle theta. This means since we have uniform motion, the velocity is constant, that the x component of the velocity at any time t, v sub x, is simply the initial x component of the velocity vector. The x component of the displacement s of x is v sub x of I times the time. The total force along the y-axis for projectile motion is the gravitational force. This means that the second law applies. The y component of the equations for projectile motion are simply the equations for free fall motion. Let's do an example. Two hilltops are 152 meters apart. A cannonball is fired horizontally from the leftmost hilltop, which is 38 meters above the ground below. If the cannonball hits the top of the rightmost hill, which is 20 meters above the ground below, what was its muzzle velocity? Keep in mind that when we analyze vector quantities such as velocity, acceleration, and force, we must always consider the x components and the y components separately and independently. Along the x-axis, there is no force at all if we ignore wind and air resistance. Therefore, at all times during the motion of the cannonball, the x velocity is constant. However, along the y-axis, we have an unbalanced force, the weight force, acting downwards on the cannonball. This means that the magnitude of the y velocity, or the speed, is constantly increasing in the downwards direction. Let's examine what we can tell from the problem statement. Since the two hilltops are 152 meters apart, and the cannonball was fired from the top of the leftmost hilltop and hit the top of the rightmost hilltop, this tells us that the x component of the displacement vector s of x is 152 meters. Since the leftmost hilltop is 38 meters above the ground below, and the rightmost hilltop is only 20 meters above the ground below, this tells us that the y component of the displacement vector s of y is a negative 18 meters. going through the guess problem solving method. We have for G the givens. The x component of the displacement vector s of x is 152 meters, as we've seen. The y component of the displacement vector s of y is negative 18 meters. The initial y component of the velocity vector v sub yi is 0. The y component of the acceleration vector is the negative acceleration of gravity, or minus 9.80 meters per second. And a sub x, the x component of the acceleration vector, is 0. The unknown, or the u in guess, is what was the muzzle velocity of the cannonball. Symbolically, this is Vx initial is what? What is the equation? To find V sub x of I, we can use S of x is Vx initial t. We know S of x is 152 meters. If we can find the time, we can use this to solve for what we're looking for. To find the time, we know the displacement in the y direction is minus 18 meters. Therefore, we can use S of y is Vy initial times the time minus 1/2 gt squared. Initial y velocity is 0, so that takes this term out. Substitute and solve. We first need to solve for the time, and so we use this equation. Substituting in for S of y, we get minus 18 meters. For Vy initial, that's 0 times the unknown, the time. That takes this term out. Minus 1/2 times g. That becomes minus 1/2 times 9.80 meters per second times the unknown t squared. This becomes minus 18 meters is minus 4.90 meters per second times t squared. And then algebraically solving, we get that t is the square root of minus 18 meters over minus 4.9 meters per second to 4 significant figures. This is 1.917 seconds. Now we're ready to solve the problem. Use this equation now. Since we have the time, we can say S of x is Vx initial time. Substitute in for S of x with 152 meters. That's equal to Vx initial times 1.917 seconds. And solving for that, we get that Vx initial is 79.3 meters per second. Now it is time for you to try some homework problems.